Hello all. Thank you each and everyone for being here with us today. We are pleased to welcome all of you in our today's webinar on challenges to monitor solar PV plant in India. Let me introduce our today's presenter, our CEO and director, Mr. Somashekar T H. He has more than 27 years of experience in power sector, automation, telecom and semiconductor. I hope this webinar will turn out to be very informative. So without stretching my introduction further, let's start our today's event. Over to you, Mr. Somashekar.
Thank you, Ritika, for that introduction. Good afternoon, ladies and gentlemen. Thank you so much for taking your time off today and joining this webinar. So we founded Enerman with the mission that we need to provide a monitoring platform that could really help people conserve energy. So that was the mission. But in today's webinar, I'm not going to talk anything about our solutions or about our product. So this is not an selling session, I would say. The whole intent is to share some of our experiences from the field. These are actually real experiences, what we gained as we were doing O&M. So I'm going to talk about our experience in the challenges, actually, what we have seen in the plants in India. As you all know, we Indians are special. We have a different culture. Maybe because of that, even the plants which are set up in India are slightly off. They are actually of different nature, I would say, in many aspects. So I'm going to touch upon that and see what are the challenges. Now, where does our experience really come from? So I'll just give a brief history about our company. Enerman is started, it was founded by the people who built Avi Solar. Now, Avi Solar is in the industry for quite a while now. And a brief history here. Avi Solar has got experience of O&M on over more than 2 gigawatts of plants. So that many assets the team has managed. It's not just O&M. We also have experience in building plants. So we did EPC then, design PMC activities. This really helped us to understand all the nitty-gritties of the plant. We have a large engineering team, and the experience I'm talking about is acquired from this team. And of course, Avi Solar was judged as one of the independent O&M service provider back in 2017 by the GTM report. So the same team built this company called Enerman. It's basically a subsidiary which was launched in the year 2019, this last year. And the mission, as I told earlier, is to provide IoT-based remote monitoring solution specifically for solar PV plants. This year, we are fortunate enough to be recognized as one of the top solar data analytics company. Right. Okay, so now without delay, let's actually see what are the pain points in the PV plants in India. Now, as you all know, we Indians are very good at engineering, right? I think every year there are lakhs of Indian engineers who not only serve our country, but as well as actually rest of the world. So this solar PV plant is actually very special because every discipline of engineering is involved in construction of this site. So what are the civil engineering challenges, right? So we have created some problems for ourselves. So this might look very trivial to you, but then look at the kind of problems it can cause. A bad civil layout, it can really, so these are actually some real pictures from the site wherein during the monsoon time, really poses a lot of challenges. You can see the water gushing out, and the steam combiner box is just at the verge of getting doomed. Now, if that is a civil engineering problem, then let us look into other engineering disciplines. Again, the reason for this is the plants were set at stringent deadlines, unskilled laborers, no supervision, right? These were the main causes. Now, moving from civil to mechanical engineer. So, what has got a mechanical engineer has got with the solar PV plants? Of course, the structures, right? Now, are they designed well? Only time will say, right? Many of the plants where we have seen there is no proper guiding mechanism for the cables, and a small spark can really cause devastating effects, right? So in this specific case, you can see that actually it's totally burnt out the land out there. So this can be really very costly. What about electrical engineering? Electrical engineering is, I think, there is a fundamental thing for any solar PV plant. So we have seen a lot of ground defect faults, then bad glanding, right? These glands are not done properly. We then, you can see the way these glands are terminated here. So those, if are not done properly, if the workmanship is poor, you can see that actually these glands are blackening at the end, and there are losses everywhere. So poor termination is another major issue on most of the solar PV plants in India. Okay. Now, well, we finished with the civil, mechanical, electrical. Now the electronics part of it. There's quite a lot of electronics in the plant. And of course, the one which is open out in the field, it comes with a lot of enclosure, IP66 protection, all that. But look at, in this case, I don't know if you can see there out in the screen, but there's an actually lizard out here. These lizards are enough to destroy the electronics, and the generation is impacted. Now, what is the problem here? The installation. The gland is really missing. So your box is not IP65 compliant anymore. So these are actually the real life problems in the field. Well, the question is, does remote monitoring help? Well, of course, it does. You can put as many engineers as possible in the field. You can have actually a lot of technicians, but can they see the, without checking it here or without physically measuring the current or the temperature inside the combiner box? He doesn't know how much a combiner box is really heating up. We have seen some very problematic cases. Similarly, in this particular case, it is a rooftop. And how would you know that actually a panel is totally displaced? So, my dear friends, monitoring is definitely needed. So, this I call it as the number one challenge in the PV plants in India. That is, making customers believe that a remote monitoring system is needed. As you all know, the main goal of setting a PV plant is to generate power, and the customers are happy as soon as the line is charged, the inverter is switched on. So till date, our experience says that most of the clients or the customers, they think that SCADA is an optional feature. So this I categorize as number one problem. Now again, it is my opinion, if you put it that way. I just want to know from you. So I see that many of the participants are from very large companies. You have been managing assets from a long time. So just to make this interactive, I'll just share this question out in the on the screen here. So just let me know if you too believe that this is a real problem. So let me just post that question here. I just want to have an actually a rough idea from your audience. So I'll just launch a poll here. So the question is: most Indian customers believe that remote monitoring is a low priority feature. So I just want to know your opinion. I think my question should be out there. If you could just choose answers, so that would be a great help. Okay, that's really good to know. This is a fantastic improvement, because what it really says here is 78% say it's false. So they don't think it's a low priority feature. They think it is an important feature. I think this is really interesting. So thank you so much. I'll just move back to moving on to the next challenge. So what are the problems with the installed SCADA systems? So now that you two voted that this is an important feature, and we do see that trend, the point that actually most of you joined this webinar, I'm very sure you are very serious about this monitoring business. So now let's look at those places wherein the SCADA is already installed and what are the real challenges we face. So before that, let me just categorize our SCADA, or the typical SCADAs, into three different buckets here. So one is the rooftops. Here, mostly I'm talking about industrial and commercial rooftops. I think residential people, uh, they are not worried too much, I would say, on the generation. But yes, industrial and commercial rooftops. Then we have this utility plants. I would classify this as small to medium, so 1 megawatt to 30 megawatt. And the last category are solar parks, which are actually are large utility parks, which are more than 50 megawatt, 100, and now even we'll see 300 350 megawatt sized single blocks I'm talking about, right? So these are the three classifications. Now, how do people monitor these small rooftop systems? Usually the inverters, the string inverters, they have this built-in monitoring features. That is one system which they use. They also use some third-party data loggers. There are very low-cost data loggers which are available. You can just hook into the Modbus TCP or RTU ports, and actually you get a data out there. Now, most of the cases here, these systems, they don't have an WMS or the weather stations. They don't have MFMs or actually energy meters which are compatible with Modbus or actually which can be interfaced. So these are the set of drawbacks. So however, I think the clients are really satisfied with just monitoring the generation under this sector. Now, the second type, which I feel actually is where our majority of plants fall into. So here, with the data we have seen that most of the SCADA systems are packaged with the inverters or SCBs. For example, people who purchase ABB inverters, they have purchased the ABB SCADA because they got some discount there. Or actually, the ones who purchased the Schneider inverters, so they too have a Schneider make SCADA. Similarly, people who have purchased Trinity combiner boxes, so they have given a complete SCADA for the systems. So for this segment, I would say these were sold as a package. And mostly these are all PLC type with local monitoring only. We have seen many cases, you can just see the screen and you can't even download many of the reports. There are very limited features. They can't push data to third party servers. So if you want to really use some forecast agencies, this is a must, but you can't push the data. Also, they need lease line connections or high bandwidth internet. So the items I highlighted in red are actually I classify as a limitation of the SCADA. Now let us look into the third sector, that is large plants. Well, definitely in these cases, our clients had some consultants, very large consultants who have advised them which SCADA to buy. So naturally, well, we would say in our experience, there are some top class SCADAs which has been chosen. So the tier one global SCADA, I would call it as. Well, these SCADAs are one-time configuration. So configuration of this SCADA takes a very long time. We have seen engineers spending several weeks or months sitting in the plants configuring the entire project. Of course, there is complexity involved. Actually, we cannot discount that. Again, our understanding here is these SCADA systems are very rigid in terms of feature. If you want to add some features, I think that's highly impossible to get it. They also need high bandwidth internet connections. And one of the issues what we have seen while doing the O&M is a poor service and support by these large companies, especially when there are field issues. And these SCADA systems are actually migrated from the industrial world. Well, when I say industrial world, no, they have been working with the legacy technologies like OPC, one of the very standard interfaces. So no problems with that. But then lately, people have migrated to FTPs or APIs. So these are all actually emerging technology, which really enables IoT kind of a system. So this, my dear friends, are the classification, and this is the kind of SCADA in our experience we feel customers have invested on. Okay, let's see actually what the problem here is. So the primary goal of a remote monitoring system is, I'm very sure you want an alert. So it should alert you when there is a problem, right? So the SCADA system should pinpoint to the equipment that has failed. If an inverter is broken down or an WMS is down, you need to have the alert, and also you need to know which one has failed. It should tell you what area of plant needs attention. So this specifically, I just put this point when it comes to the string monitoring. If you incorporated the string monitoring on your or zone monitoring on your PV plants, wherein you can focus your attention on a certain block, because otherwise in a large SCADA system which is spread around in acres of land, it's very difficult to identify the strings. So the expectation is the SCADA should tell you which block needs attention. So finally, to sum up, what it means is your expectation or any client's expectation is it should help you to make an informed decision. Now, look at this picture. If you see actually overall analytics, so this is how the analytics engine works. So this, the first figure, what you see, I would relate it to the field data. It comes cluttered from everywhere in the field. Then you use a logic, you analyze it, you group it, and based on some patterns, you make informed decisions. So this is an analogy I'm trying to give because the next challenge I'm going to talk about is the field data. This, my dear friends, is the biggest challenge in the PV industry in India. There are a lot of companies which can analyze, which have or actually claim to have, they've got actually huge AI engines. But then if the data is not good, naturally the decisions will be false or actually faltered, and your analysis will not be correct. So challenge number 2 is the data quality issue. In all the PV plants which we have seen, we have this as a primary problem. Now, how does this problem surface? I'm not going to show you the complete architecture because I know the invitees today here in this webinar. So most of you are domain experts, and you are aware of all these equipments. So I will start with the combiner boxes. So this is one of the critical equipment, especially when you need to monitor the string. So the most of the cases we see the monitoring sensor PCB or the entire sensor board has failed or burnt. The reason being these are actually spread across the field, and these lengthy cables are very vulnerable to noise and surges. We have this communication ports damage for the same reason. Right? The power supply failed again due to surges, external surges, and we see this more actually as the monsoon season is actually coming up. Right? And communication cable getting damaged is very frequent. So these are the main challenges. However expensive your monitoring box be, these kind of problems we are seeing it actually is very common in all our PV plants. So from combiner boxes, the next big equipment in the field is the inverter. So I'm just referring to the central inverter here. Although we have seen a lot of plants with string inverters, these days those are really surfacing up. But the central inverter is actually the biggest one. Actually, I'm just talking about. Communication port not working is one of the major issues which we have seen, which takes a lot of time to be rectified, because the response from inverter guys for that port, it really goes back and forth. They try to say, okay, the port, everything is fine, the inverter is generating, because for them the communication port is of the last priority. As long as the inverter is performing, they're okay with that. So the challenges we have seen here is the communication port not working. And as you all know, most of the time the communication ports are actually daisy chained, and we have seen a lot of looping issues here. And when we're using fiber cables and switches, media converter, many times the data from the inverter room is not reaching the master control room, that is MCR. So this is how the data gets really snapped at the inverter room itself. Okay. So next big item, weather station. Now, in the entire bill of material, weather station is such a small thing, but it has got a very big significance, as you all know, right? So weather station, when you are making, or actually for any performance metrics starting from PR, so this is the baseline data. It's really surprising that most of them, they really give least importance to this weather station. But the data is very critical, because if this data is not right, your entire performance matrix goes for a toss. It just doesn't make sense. And what are the problems actually we face in weather station? Sensor failures are very common. Again, when I say sensor failure, these are the pyranometers I'm just talking about, right? Calibration issues, they need to be calibrated time and again, else the data is really skewed. And one other problem we have been seeing recently is the configuration being reset. So what I really mean here is there are some settings to be done inside these weather stations, because most of them, they convert the analog output into a Modbus port, and there is some configuration parameters which defines the sensitivity and gain and all those amplifier related items. So if these parameters are reset, we see that the data coming out of these weather stations are all wrong. Okay, and of course the cable damages is a very common one. So we touched upon the string combiner boxes, inverter, and weather station. Now, what are the other things which comprises for the SCADA? It is the entire networking infrastructure. And again, at the beginning, I told you, we Indians are very special. We have a great culture with us. Every day in our city, we see these roads. It is cleaned properly. Everything looks nice. Next day, it is dug again. And after 2 weeks, another contractor comes and digs. Well, the experience is not much different in the solar PV plant as well. Although it is controlled definitely, but we see that the cables are getting damaged, and people have to, when they're doing some unskilled work, this is a common problem we have seen. And one cable cut anywhere in the loop, of course, you have an actual ring architecture. If a cable is cut at one place, it is supposed to, the data should be collected on the other side. But then there are so many other variables coming in, and we have seen this is another big reason why you do not get data properly at the master control room. So cable damages, switches, and the LIU failures. However, again, I would have a disclaimer here. The switches and LIUs, the media converters, are quite stable, and the percentage of failures as compared to the SCB monitoring electronics is much lesser here, right? So other soft issues like IP conflicts, and whenever we have seen this problem usually when the string inverters are being replaced, there are the settings has to be done properly, else actually there are these conflicts and you don't get the data out there in the cloud. And internet failure is also another issue. So what happens to your data if the internet is failed? Is it available locally or it is gone? So these are some things which really should be considered when you are choosing the SCADA. So to summarize on my second point, the biggest challenge the PV plants in India is data retrieval, right? As you all know, the plants are spread across in such vast areas. It's very, very important to have clean data. Only then you can make the discussions. Now, again, I want to give you some proof. I'm not just talking about a theory here. I'll just give a few examples out of our own experience in last 11 months. In last 11 months, so this is actually our portfolio, how it looks like. We have got around 910 megawatt plants which are live. In that, believe it or not, 300 megawatts are retrofit. And another 350 megawatt, we also call it as retrofit, but we didn't replace the existing SCADA, but it is an add-on feature. So I just want to touch upon a few of these interesting cases of retrofit. Again, I will not disclose the names of the companies because the intent here is not to tell if any product is good or bad. I'm just talking about the challenges we have here. This product might be the best, and globally they have actually a lot of clients, but then there's something missing when it comes to setting up these monitoring plants in India. So this particular case is an 10 megawatt plant wherein a lot of hardware failed, and when the client asked them to replace it, the costs were very high. Even the renewal fees was extremely or exorbitantly high. And this is a case wherein we replace the complete hardware. This plant is, I think, working now with our SCADA from almost 2 years, right? So next, this is again one of the top Indian companies. So wherein recently we did a 10 megawatt retrofit. So the challenge here was the data was not retrieved at the MCR. So we had to work on the debug lot of hardware. However, majority of the hardware was reused, and now we are working on another 20 megawatt. We then have another 55 megawatt of plant. Again, this is from a German company. The SCADA was restored, and the hardware provided by this company was extremely good, very high quality, and wherever possible, this hardware was reused. So sorry, there's some questions coming in, and there's some people in the waiting room. Sorry about that. Right. Okay. So 12 megawatts of a plant here, the client replaced just because the AMC cost was too high for them. So 50% of the hardware was actually replaced, and we made use of the other one, right? And there is another case. This is again a Japanese service provider, excellent SCADA, but then here they could not enable the feature of pushing the data to a third-party server who was consolidating the entire portfolio. So this was actually their challenge, and they moved to our SCADA, and we were able to uh, push their data into their system. Okay, so another large American or the UK-based company here, a 30 megawatt. Here we use the entire data. The challenge was they could not get the data remotely. It was only available at the local uh, plant level, and we had to add one additional hardware and push the data into the cloud. Now, the last one which we are proud of is an 350 megawatt plant. This is actually a very large plant. Now you can actually imagine the size and the complexity involved here. The requirement was actually unique. The SCADA was actually working well, so no problems with that. But then they had to implement a partial PPC. There's a power plant control, and they wanted to control all these inverters individually, blockwise, based on the guidelines from the SCOM. So they wanted to schedule all these controls. So this was actually a total customization work, and our SCADA is working with another SCADA. In this case, it was an add-on feature. That's the reason I call it. And this was kind of implemented in 5 weeks. So these are actually all real proof to show that every plant has got a challenge, and all these challenge people migrated not because actually they were unhappy with their front end. They were happy with the graphics, the reports, the analytics they provide, but none of these companies could fix the problem of retrieving data from the field. So this is what I'm going to stress. Please look into the perspective of getting the data cleanly. Only then you can make informed decision. Now, the challenge number 3. As you know, the solar PV plants mushroomed in this country in 2015, 16, 17 timeframes. And every electrical contractor became an EPC. They had to make their margins, they had to meet stringent deadlines. They acquired, or actually, they put some random SCADA in the bill of material, and so finally got the project completed. So, because of what has happened, there are actually multiple SCADA, and with different sites, actually, you get different SCADA. So, the challenge here is, can you really monitor them with different logins? So, current scenario, as you all know, there are many companies pitching in from outside India. They're coming in here. They are acquiring a lot of these projects. And the challenge they face is to monitor every plant, they need to log in separately. So this I would rate as actually the number 3 problem in terms of monitoring plants in India. And why is it important to have in all your data in a common platform? As explained earlier, finally, the SCADA has to make a decision based on the data. And all this data has to be consolidated on a single database so that you can make comparisons, you can make analysis, and take informed decision. So what customer really needs is a single window to log in and manage all his assets. Okay. So with that, I just want to summarize the 3 challenges I was talking about. Number 1, remote monitoring is critical. So this is something we as an industry, we have to push, because the plants are built to last for 25 years. And as you all know, the problems start increasing as the years roll by. The focus only on cutting the grass or cleaning the modules by an O&M operator, I think that the time is over. We need to really monitor remotely. So this is the first challenge which needs to be addressed. Second is we need to focus on the ability of a SCADA to collect quality data from the field. So please look into this aspect. However, good analytics, I'll just repeat that, is if the data is not good, you will not get great results. The alert will be a problem, right? And should have a single login to monitor your entire portfolio. So amongst all this, I again would rate the ability to get the data properly as the biggest nightmare in the industry. Okay, so with that, again, I just have one last question for you. I'll just have that actually on your screen. So basically, what is the biggest challenge you face? Because most of you are dealing with this SCADA and remote monitoring. So what is the biggest challenge you face related to the plant SCADA? So I just gave multiple choices here. So maybe that's the reason. So the biggest challenges we see here as per the uh, results of the poll is 80% say that, or 73% say that data retrieval from site is the problem. Internet issue also actually is rated quite high, and the poor support from SCADA supplier is the biggest challenge. So if I share the result, I think you people should be able to see that as well. Yeah, I think actually you can see the results here. So this definitely helps us to really look into the data and see what can be really done if anything is applicable to our company as well. So thank you so much for your inputs here. So continuing on, so I spoke about the data retrieval, and this is a small part of the entire SCADA. What you really expect from a SCADA system is much more, right? The ultimate goal, I believe, is that we need to really understand the losses on each segment. If you see this entire architecture, the flow of data here, we need to find these losses, because year on year these losses are gonna increase. As of now, people are really not looking into these losses in detail, but then tomorrow if you want to measure the performance, you need to look into it. That's what actually SCADA has to do, right? And the buzzword, everyone is talking about predictive analytics. They're talking about machine learning, ranking of equipments, predicting breakdown of equipments, predictive O&M. So all these things are in wish list. So whichever actually clients talk to us, ask if these features are supported. As I mentioned earlier, yes, in theory, from a simulated world, if I put in data which is simulated, we can get these answers readily. But then from a real scenario, the data cleansing is something which we need to really focus on. So we will be talking more in detail on all these topics in our upcoming seminar. So today our focus was only on the challenges, and I kind of picked up the three major challenges and tried to present to you today. So stay tuned for our future webinars. So if there is any questions, you can type in the chat window. I can try to answer it right now. Else, you can also send an email to us. You can email me or actually to sales@enerman.in. We would be very happy to help you. I really thank each one of you for taking your time. So be safe. Meanwhile, I'll just look into the chat window and see if I have any more questions here. So thank you again for joining in, and looking forward to see you for our next webinar. So thank you. Be safe, be healthy. Thank you.